Yeah, hello, thank you. And good afternoon, everybody. Glad you're all enjoying or joining my talk today. Let me share my screen and then we get started. So, I'm going to be talking to you about a real life story, a real life case study to be specific. If you want to reach out to me during the talk or after, my Twitter handle is on screen right now. And I'll be happy to answer any questions, share my slides, or discuss the topics that are in this talk with you during the conference or after. So let's get going. Like I said, this talk is about a real life case study about a project I was a part of in late 2017 to late 2018 at a large semi-government organization in the Netherlands. I cannot disclose the name, but suffice to say that they are in a very competitive European or even worldwide market where customers get to choose which of the organizations, of similar organizations in other countries, such as Germany, France, the United Kingdom, where they do their business. So this is a very competitive market, and that shapes some of the thinking that I'm about to discuss in this particular project. So I joined at the end of 2017, and as I joined there, this is the situation I encountered. This was one department within that organization, and they had been building some software for a while, an online platform that would be accessible through the browser directly, but also through mobile apps on your iPhone and your Android devices. And powering this platform was a sizable monolithic application connecting to a number of databases, SQL and some Elasticsearch and other stuff. And there were a few smaller services surrounding the monolith, but the monolithic application was the big part. Now, key thing to point out here, the monolith was relatively well tested, but we'll get back to that in a little bit. Now, supporting this monolith were 4 teams, and those teams were called topic teams. Reason being that the domain that this application, this platform was in, could be sliced in roughly 4 equal parts, right? So there was a part where people could buy tickets. There was a part where people could log in and view their profile and maintain some information. There was a search component. There were APIs and a bunch of other stuff. And so all this stuff was essentially divided in 4 pieces and assigned or distributed roughly equally over the 4 teams. Now, 4 teams of roughly equal size as well, 2 pizza teams located in their own team room back when it was all physical. And these topic teams, these 4 teams, had a special role from time to time. And that special role, they would become the fire team. So, and this role would swap from team to team to team. And the fire team, or being the fire team, added another set of responsibilities onto the ones that a team already had. And the first one, the biggest one, or potentially one of the important ones, is triaging bugs as they come in. So an issue comes in, right? There's a problem on the site, there's a problem in the app or in an API somewhere, and now the important thing is to decide what the impact is of this issue, of this bug. Is it something that is causing a lot of customer impact? Then we probably should fix it right away. And there are 2 other gradations. So there's also the version where this is an annoyance, but we can deal with it in a few weeks and plan for it with the rest of our work. So bug triage is an important responsibility for a fire team. Now, another responsibility is updating all the packages, all the dependencies that this application has, right? There's a lot of open source components that pretty much everyone uses. And if there's a version update on those open source components, then we want to we want to follow relatively closely behind. Maybe not the very latest version, but one version behind or two versions behind, but not much more, right? Because the cost of updates becomes significantly more as we postpone those updates. So we wanted to keep up to date with that. But the most important part of the responsibilities of the fire team with respect to this talk today is rolling out a release. And let's take you through a typical release within this platform, of this application. And the release checklist that this organization, this department used was pretty sizable. When printed, it would net around 5 to 6 pages A4. It was a pretty long checklist. Lots of steps, lots of manual steps. And the interesting part was that it was also manual, of course, but there's many steps, and that people tend to skip things or forget things, especially when under pressure. Okay. And this release schedule or this release checklist was executed in the ideal case once every 2 weeks. Now, this department would start their sprints on the Monday and then end the sprint on the Thursday of the next week, right? So it would be a sprint of roughly 14 days. And as the sprint ends, that would start the release candidate of a release, hopefully. Now, in reality, so in the ideal situation, we would have a release every 2 weeks at the end of a sprint. However, in reality, it would be a multiple of 2 weeks, 4, 6, or 8 weeks we've seen, right? In the ideal situation, we would have a release candidate made on a Thursday at sprint end. And on Monday, we would test it. And on Tuesday, we would roll it out, assuming there's no real issues with the release. Now, we did some tabulation, and we counted that doing this release cost a fire team roughly 2 to 3 days of manual work. So that's for the entire team, okay? And that's a pretty sizable amount of investment we do in a release. And this is time we don't get to spend on other things. So all these issues and this situation in conjunction with the competitive market that this organization is in, led to a few goals. The first goal is to reduce cost, not by firing people, but by actually having these people spend their valuable time on more interesting things rather than 2 to 3 days of manual work on a release. Second goal, we wanted to have faster feedback and the ability to do more experiments. Faster feedback in terms of the thing that we build, does it pass the tests? Does it work? Is it viable? But also, is the thing that we are building useful to our customers? Are we providing value? And then experimentation on a large scale where we can verify whether the thing we are thinking is useful actually is useful, and do some A/B testing or do focus groups or stuff like that. And we wanted to be in a position where we could rapidly run these experiments for a few days time tops, because that would give us enough info and then move on to the next experiment or the next iteration of the experiment. Another goal is that we wanted to reduce toil. Now, if you look up the definition of toil on the internet, you would see that it is the kind of work that is associated with the running of a production service that tends to be manual, repetitive, automatable, tactical, and devoid of enduring value. And also, it scales linearly as a service grows. So this is work that is essentially not interesting, right? It is repetitive, it's mundane, and it can be automated. So we wanted to get that number. You'll never get it to 0, but we wanted to get that number to a manageable number, essentially. So with these goals, we basically chose our strategy. And the backbone of our strategy is continuous delivery. And I'll briefly touch on why continuous delivery is such a big thing here and why we chose it. Because continuous delivery is all about making things small, and that's the key part here. Making things small will actually allow you to earn value faster and reduce risks at the same time. And that may sound paradoxical, but look at this picture that should be on your screen right now. On the left side of the picture, you have an infrequent release schedule. There's only a handful of releases, and there's a lot of time in between those releases. What we do here is, as we are coding and we're building products, we're building up inventory. Okay, we're putting stuff on a shelf. This stuff is not ready or is not used in production yet. So we're not even sure whether the thing that we're building works technically and is useful functionally, actually adds value to our customers. So all we're doing here is building up inventory. And from a lean perspective, we're building up a potential source of waste. Now, as we release, as we go to production, you hopefully turn all that risk into value, right? Hopefully. So on the right side of the picture, you would see, a frequent release schedule. So there's a lot of smaller releases, and the time between the releases is significantly shorter as well. So we still build up some inventory, we still build up some risk, but the amount that we can build up is substantially reduced because we release far more often, right? So again, we reduce risks and we earn value faster if we go in small batches. Now, research has shown that this is one of the key differences, if you will, between high-performing and low-performing teams. So the Accelerate book, for example, shows that high-performing teams deploy far more often with a lower change failure rate, with a lower mean time to recover, and a faster change time than a low-performing team does. And that's because they apply the principles of continuous delivery successfully, okay? Now, let's go into the actual approach of this project. We split it into three phases, roughly. Before I go into those phases, though, one thing I need to mention, I described the monolithic nature of the platform that we're building in this department, right? What we chose to do was not split it into services or smaller pieces before we go ahead with all the continuous delivery stuff. Why? Well, one of our big goals is reducing toil, right? We want to get rid of the manual, repetitive, boring work. The problem is, if we would have split the monolith first, we would end up with lots of small pieces that have lots of small steps. Ergo, we have more small steps, or more manual steps, I should say, than we started out with. So our strategy is first automate and then split. So the first phase is then to automate, but also increase our release cadence. The second phase, we're bundling all our individual components into a single pipeline that goes to production. And the third one is we do a bunch of improvements to our pipeline and our testing setup. So the first phase is all about increasing release cadence, right? And I was describing to you how in the ideal, absolute ideal situation, we would have a release cadence of once every 2 weeks. In reality, it turned out to be more than that. Now, in phase one, we started to go to a weekly release cycle, every week, not with gaps in between, but a release every week. Now, the nice thing about doing this, about going to this cadence, is that it acts as a forcing function, right? It makes a lot that was associated with the release checklist, with the manual nature of the release process. It makes it very visible, and that's what we want. We want to have that pain visible so that we can fix it. And a big part of the fix is automation, right? All the steps we do in the release process, we can automate them or change them into scripts, build scripts, batch scripts, whatever. And we would end up with a situation like this. We would have a pipeline that would start building and packaging our application, right? Having some sort of an artifact at the end, then running a whole series of automated tests, deploying it to an acceptance environment, and ultimately deploying it to the production environment. However, between acceptance and production, we would have a bit of a wait. Why? We were not ready yet for our application to go to production completely automatically. We were not at the point that we had the confidence to do that yet. So we put a button in between acceptance and production. Basically, whenever a new build would end up on acceptance, we would signal testers, POs, and whatnot. And at some point, the build would be classified good to go. And if not, we would simply start new builds until we were at the phase that the build is good to go. And then we would push the button and we would deploy to production. Now, the pipeline looked a little bit like this. This was all done in Jenkins, and that's not to say that Jenkins is better than all the other offerings. At this point, they're all pretty similar in what they offer and the pain they cause to some degree. We use Jenkins in this particular situation, and you see the first half of the pipeline on your screen. So basically what this does is pull in our open source dependencies, run a bunch of unit tests, deploy a package to our artifact setup, and then roll it out to acceptance. And once that is done, we deploy to production, which is basically a bunch of infrastructure scripts where we deploy the actual code to the servers, and then we verify at the end, and we're done. Now, all in all, on average, the two pipelines combined would take about an hour and a half, assuming that someone would immediately mash the button. But of course, we took a little bit more time than that. Now, next to the automation, we introduced a few changes to our way of working as well. And those may even be more important than just the automation. The big one was that we introduced pair programming. Now, some would say having pull requests to do reviews is better than having no reviews at all, to which I would agree. But doing pair programming is the superior form. Ensemble or mob programming and pair programming is basically more than one person behind a computer at the same time, which is a superior form of developing software, because not only do you have knowledge transfer between peers within the pair or the ensemble, especially when you have people with less experience and people with more experience, you also have design decisions that you collaborate on real time. You have inline and synchronous code review. And the best part of it all, which you don't get in a pull request, you can discuss about code that doesn't get written. You discuss why the code doesn't get written or doesn't have to be written, which is something you don't see in a pull request. Now, pair programming can be pretty labor intensive, can be tiring for some. So we would switch pairs out regularly and have breaks and all the rest of it. It was also something that we encouraged and not enforced, but it is something that dramatically improves the quality of your application. Another principle that we put down was the Boy Scout principle, essentially. Leave the campsite in a better state than you found it, and when contrasted to code, don't leave any broken windows. The broken window problem or broken window syndrome was described in a pragmatic programmer as neglect that accelerates code rot faster than any other factor can. And what we mean with this is if you spot an issue in the code, which you can fix quickly or in a reasonable amount of time, and the issue is, for example, there's something that doesn't match design principles, code style, whatever it is that your team has agreed on, and this piece of code doesn't match the agreements, fix it. Because again, neglect accelerates rot. And that's what you want to avoid. Then we put in a bunch of monitoring, getting some sense of the health of our application and what it is doing. But most importantly, we measured how we were doing on the continuous delivery journey. And Steve Smith describes in measuring continuous delivery, a bunch of measures and a bunch of tricks that you can use to measure your continuous delivery trajectory. And that's what we did as well. Not to hold it against people, but rather as a thermometer. How are we doing in terms of our CD journey? Okay, moving on to the second phase, which is where it gets interesting, because now we replace that button between acceptance and production with a robot. And so what happens is basically that we automatically jump from acceptance to production. Now, and this is called continuous deployment. And continuous deployment says that every commit that passes the tests goes to production. And that's a pretty cool thing. But it requires a few things. One of those is having the ability to do zero downtime deploys. And we solved that by introducing rolling deployments. Now, a rolling deployment is basically where you have a load balancer between your service and your user, your customer, your consumer. And you have multiple instances of your service. And they share roughly the same amount of traffic amongst them. So what happens when you release a new version? Well, you start it, and as you start it, you replace an old instance or an instance of the old version with an instance of the new version. And you do that one by one until you have replaced the entire fleet of instances of the old version with instances of the new version. And if you do that right, nobody will have noticed that you just upgraded your version. Now, an important thing to keep in mind when you do continuous delivery is pipeline failures. Pipeline failures come in many forms and shapes. Flaky tests, which are tests that succeed one build and failed the next build. Timeouts, when you have websites that respond slowly or other things that cause your test to time out. Network stability issues, for example, but also external dependencies in tests where you actually call APIs even, and you should have been using a test version or a mock version. Now, the key thing is here with flaky tests, if you cannot trust a test, is if it doesn't add any value, remove it, because you're probably going to work around it at some point, which is more dangerous than not having the test at all. And if the pipeline breaks, if it fails, then stop the line, because we're not doing any manual releases anymore. So if the pipeline fails, that becomes an immediate priority one thing to deal with. And you want to quickly know that the pipeline broke, and that you can use all sorts of extreme feedback for that. Sirens, lamps, screens, Slack notifications, automatic nerf launchers powered by USB, whatever you can think of. And then it turned into this single pipeline, which takes about 20 to 25 minutes to roll out a change to production, which is pretty cool. Closing off with phase 3, which is where we change our pipeline a bit to make it more, to make it faster. So we scale horizontally and vertically, buy a bigger box and buy more boxes, buy more built servers. And we do some parallelization to, run all the tests at the same time. And if one of the tests fails, then immediately stop the pipeline. And we also improved our testing quite significantly. Now, some companies, and this company was a little bit like that, but not as extreme as the picture would show, you would have the of testing. Lots of manual testing at the top and not a lot of unit tests at the bottom. And we improved that by flipping it around and going to the test pyramid.
Hi, Michiel.
Hi.
Unfortunately, we're running out of time at this moment.
Okay, that's unfortunate.
Sorry to interrupt you, but will you be able to stay on the chat so you can interact with the participants? Should they have any questions?
If I can just wrap it up in terms of results that we had, then I'll skip over one last part. So,
sure.
Results and the takeaways. So the learnings that you need to take away, and I'm sorry for running over, but pipeline speed and stability is key here, right? Testing your pipeline is something you also want to do. and pay attention to the way of working, such as pair programming, developer discipline, and stopping the line. Now, some cool statistics before we close off. We run 4,000 tests on average per deployment. A single pipeline run at the end of this project took about 10 minutes, leading to 1.5 hours from development to production. And in 6 months' time, we did more than 5,000 deployments. Thank you again. And again, sorry for running over, but I'll be around on the chat if you want to know more. And the slides will be available online as well. Thanks again.